All right, let's take a look at 6-5 algebra homework answer key. This is the answer key. So we're going to go over the homework problems. And as stated in class, we are adding rational fractions. Rational typically means that they are can be represented as a fraction. So we have two fractions adding together, and we know that with any two fractions, we can't combine them until they have like denominators. And in this case, they do have like denominators. So we, not crayon, so we can combine their numerators. And this sign is always attached to that term. So since we have like denominators, we're going to put the numerators together in the numerator. And if they are like terms, which they are in this case, they are both x to the first, we can combine their coefficients. When we have like terms, we combine their coefficients. 1x plus 3x gives us 4x over 12. And now we look to reduce. And this looks like section 6.1. So 6.1, we were reducing fractions, rational fractions, and this is why we learned that technique, because now in 6.5, we're going to add, and now we have to reduce. So it has a common factor. 4 is multiplying x, so we can cancel by 4 in the numerator and 4 in the denominator, which is a value of 1, which keeps it equivalent. So we'll cancel that. We'll cancel the numerator by 4, divide by 4, divide by 4, and it gives us x over 3. And that would be our answer. Number 2, again, we have like denominators, but this time we notice that their numerator, remember how I said this sign is attached to that term. So when we rewrite it in one numerator, we have 7x minus 4x over 15. And something that we have to remember with fractions is when we have a fraction like negative 1/2, that negative can either go in the numerator or it can go in the denominator. It's not going to go into both. There's only one negative, and it go in the numerator or it can go in the denominator. So with this problem, I put it in the numerator because if I put it down into the denominator, that would make negative 15, and then these would not be like terms anymore. That would be positive 15. This would be negative 15, and we wouldn't be able to combine the numerators. So that's why that negative goes up to the 4x, because that keeps our denominators as same like. So we have like terms in the numerator. 7x minus 4x gives me 3x over 15. We can reduce both of those. They have a common factor of 3. 3 goes into 3 once, 3 goes into 15 5 times, and that leaves me with x over 5. Question number 3, like denominators, so we can combine their numerators. 2 minus 6n gives me negative 4 over n. Those can't be reduced. I can't reduce that fraction because there's no common factor or variable. Like denominators, let's combine their numerators. Those are like terms, they're both constants, so we get 14 over 3x. We can't combine, or we can't reduce that because no number, no factor, it doesn't have a common factor, no number goes into 14 or 3. Now this is where it gets interesting. So we see this negative, and it's outside of that. It's not in that fraction. So we don't want to put it in the denominator. Remember, we don't want to put it in the denominator because it would make these two different. That would be positive 3, and this would be negative 3. So we have to put this negative up here, but you notice that we have two terms up here. So when we rewrite this in one numerator, in the numerator, we're going to write 2x minus the quantity x minus 1 over 3. Because that negative is outside of that, and that's a vinculum. So we have x minus 1 is together. So when we push that negative up to the numerator, we're going to have to push it and distribute it to both of those things in the numerator. So if we distribute, we get 2x minus x plus 1 over 3. we're going to combine like terms. 2x minus x is x, and then we have the constant, and then we have our denominator. And we can't do anything with that. That's factored. There's no canceling that we can do. Let's look at this one. Again, we have a negative that we're going to have to distribute to that right fraction. So when I write it, I'm going to write 3a minus the quantity of 5a plus 1 over 10. Let's distribute that negative to both of the terms inside the parentheses. Let's simplify. 3a minus 5a is negative 2a minus 1 over 10. Now, we can look at this two ways. Sometimes they're going to allow you to give an answer with a first term negative. All right, you will find that there will be inconsistencies in high school on what is allowed. That is an acceptable answer by some people. Other people would want you to factor out that negative. So you take the negative out and you get 2a plus 1 over 10. Now you can't cancel anything. We factor in order to see if we can cancel things. So this is an acceptable answer. Here's where it gets interesting. Or we can take that negative and throw it down into the denominator, and we can get that answer. So of all three answers, this is the one that I love. I like that one the best. However, you will find that this will be acceptable, this will be acceptable, and this will be acceptable. All three of them, but they all are the same, and they all are considered simplified. Now, some math teachers will want you to factor out that first negative as simplified, right? They don't think that it's simplified until you factor it out. So you got to sort of be aware of what the expectations of your math teacher are. I will take any of the three. I know that that was a question that you were waiting. All right, let's move on. We again have a negative that we have to distribute. So we have y minus 3 minus the quantity 3y minus 5 all over 4. We'll distribute it. Y minus 3 minus 3y plus 5 over 4. Let's combine like terms. We have y's and constants. So we have positive y and negative 3y, which makes negative 2y. We have negative 3 and positive 5, which makes positive 2 over 4. So two things that we need to be aware of. First term is negative. Second, there's a common factor amongst those numerators. So we can factor out a negative 2 and get y minus 1 over 4. And now we notice that we have a common factor of negative 2 and 4. We can cancel because that is multiplying that binomial. So if we cancel, 2 goes into that, and 2 goes into that, we can get the opposite of y minus 1 over 2. That is an acceptable answer. Or we can push that negative down into the denominator. And we can push it now because there's only one term. Remember, we didn't push it in the beginning because it would have made unlike denominators. So we can push it here because we only have one term. Personally, that's the best answer. But I'll take either of them. You would not distribute it. At this juncture, you would not give me negative y plus 1 over 2. It's definitely equivalent. Most teachers would take it, but to me, we are not simplifying. Remember, we always want to factor as our answer. Our answer should be factored. And because it was already factored up here, that's why we'd never get down to this part. But it's acceptable by some teachers. Wow, all these subtraction ones where we have to distribute. So we have x plus 3 minus the quantity 9x plus 11 over 4. We're going to distribute that negative. So that becomes negative 9x minus 11 over 4. We're going to combine like terms. Those like terms are like variables, positive x, negative 9x. The other like terms are the constants, positive 3, negative 11. And that leaves us with negative 8x minus 8 over 4. So we can factor that numerator. We always want to look, can we factor in the numerator or denominator? Much like in 6(1), where we are simplifying fractions, we're going to factor out a negative 8. We get x plus 1 over 4. We're going to cancel the coefficients. 4 goes into both of those, negative 2 times, and 4 goes into 4 once. And so we get negative 2 over x plus 1 would be our answer. We would not push that negative to the denominator because my denominator is 1. We would never write that. No, because we could push that up and write it as a whole number opposed to a fraction. All right. Like denominators, we're going to add. Notice we have a little bit more complex denominator. We've got a little bit more than just, now we've got 2 terms, binomials in the denominator. So we get 7 over x plus 3. That cannot be factored. Okay, we're going to attach that negative. So we have 9 minus 3 over y minus 6. 9 minus 3 is 6 over y minus 6. The 6's cannot cancel because that 6 in the denominator is being subtracted from y. There's nothing we can factor. There's nothing we can cancel. So that would be our answer. Number 11, like denominators. And we can do this because they're like denominators. Just because they're binomials is okay. They still have to be the same, which they are. So you get x plus 1 over x minus 2. The x's don't cancel because they're being added and subtracted. So that's already simplified. But we can write it as a single term, or a single fraction, should I say. Number 12, now we have that negative, so we have to distribute it. So we write n minus the quantity 3n minus 1 over n minus 2. Let's distribute that negative. Okay, n minus 3n is negative 2n plus 1 over n minus 2. So some teachers will allow you to give that. Others will ask you to factor out that negative. Now I wouldn't throw it down in the denominator because it's not a single term. It only benefited us when there was a single term down there. So just keep it up there. And I don't know if you remember what I'm talking about. Yeah, no, that's the bad example. This is the one, right? So we would throw it down here into the negative because there was a single term. And that looked a little bit better without those parentheses. Parentheses aren't bad. They just make it look a little complex. So either answer is okay in this case. Look what happened here. We have, these are not like terms. You see that they are different. That's x minus 5. That's 5 minus x. And one of the things that we have to be aware of in this problem is that this one is not in standard form. So the first thing that I'm going to want to do is write it in standard form. And that's when we notice that these are not the same. Okay, so those aren't the same at the moment, so we can't combine their numerators. The only time we can combine numerators is when we have the same denominators. So is there anything that we can do? Well, I don't like the fact that there's a negative there. And remember, when we see that, we factor out a negative. So if I factor out a negative from this, we get the opposite of x minus 5. Now, they're still not like terms because this has a negative, this has a negative, and this doesn't have a negative. However, remember what we can do with negatives is we can take it and move it up. So you can write this problem. You can do two things. You can combine these two, and you can write it as 3 over x minus 5 minus 2 over x minus 5, or you could have written it as 3 over x minus 5 plus negative 2 over x minus 5, meaning you threw it all the way up to the top, opposed to that sign. This is better. We don't like double signs here. This is not as preferable as this. So we are going to combine those. So not the best. But it's correct, but it's not the best. I will never write that. I will always do the left side equation. All right, so now we have like denominators. Let's combine their numerators and put it over one denominator. 3 minus 2 is 1 over x minus 5. So that would be my simplified answer. Here we again, we have a denominator that is not in standard form. So let's rewrite it. 5 over 4y minus 1 minus 3 over negative 4y plus 1. Those are not like terms. That's a horrible positive sign right there. They're not like denominators, and we have a first term negative, so let's factor it out. You have 4y minus 1 minus 3 over the opposite of 4y minus 1. And now I'm going to take those two negatives and I'm going to combine them. And a negative make a positive. So I get 5 over 4y minus 1 plus 3 over 4y minus 1. That sign just turned into that sign. So we have like denominators. We can put the numerators together in the numerator. It's a little redundant. 5 plus 3 is 8 over 4y minus 1. I can't factor the denominator. That binomial cannot be factored. And I cannot cancel the 8 and the 4 because the 4y is being subtracted. So that is actually my answer. Last one. Again, we still have a denominator that is not in standard form. So we get 5c over c minus d plus 5d over, let's rewrite it, negative c plus d. Let's deal. Notice we're not combining these negative and positive here, because this negative, you can't combine that negative because that negative is being added to d. So be careful of that. We can't combine these signs right at the moment. You have to factor out a negative, meaning that negative has to be multiplying. So when we factor it out, it now becomes multiplying, and now we can cancel it with that positive. So now we can cancel those, or combine those signs, shall we say, and we get 5c over c minus d. We're going to make that minus 5d over c minus d. And the way we get the minus is a positive times a negative is a negative. Now we have like denominators. Let's do 5c minus 5d over c minus d. Now let's look at that numerator. We can factor out a 5, and we get 5 minus c, 5 times the quantity c minus d over c minus d. And we see that we have like binomials, and that binomial is multiplying the 5. That's why we can cancel it. And it leaves me with an elegant 5. So that problem right there, 5c over c minus d plus 5d over d minus c, that equals 5. How crazy is that? Totally crazy. All right, come and see me if you have questions. Try a couple problems. Enjoy. Good luck. You're doing awesome. Did I not record this?